Hi, I'm from the Customer Success Engineering team. In this series of short videos, we'll be taking a look at recommendations for forwarding your traffic to the Zero Trust Exchange. This is Part 1, ZIA infrastructure. Let's start with a brief reminder of the Zscaler Internet Access Architecture. When a user whose traffic is secured by ZIA browses the internet, their traffic is routed through Zscaler public service edges. These public service edges have a persistent connection to the central authority servers, which enforce the policies configured in your ZIA admin portal. Simultaneously, the user's transactions and the policy actions taken are sent to the ZIA log routers, which forward these logs onto your nanolog clusters. In order for your configured policies to be applied to your traffic, that traffic must, of course, first be forwarded onto the Zero Trust Exchange. Let's take a look at how you can do this. There are 3 options for forwarding your traffic to ZIA. The first of these is to use Zscaler Client Connector, which is the recommended method for forwarding user traffic to the Zero Trust Exchange. This is a lightweight endpoint agent that is installed on user devices and will encapsulate user traffic from all ports and protocols and tunnel it to a nearby public service edge. ZCC can detect if a user is on a trusted network, as defined by an administrator, and make routing decisions accordingly. ZCC is also the agent required for the ZPA and ZDX services. It supports the most common operating systems: Windows, macOS, Linux, Android, and iOS. GRE and IPsec tunnels are transparent proxy tunnels which can be set up at known locations such as a campus or branch office. These locations have fixed infrastructure but might use commercial or commodity internet connections. This is the recommended method for forwarding location traffic to the Zero Trust Exchange. Zscaler recommends that you build tunnels from a network device that is inside your NAT firewall. This will give Zscaler visibility into your internal IPs, which will allow for significantly improved reporting and the ability to set policy by subnet for traffic types that cannot use ZCC, such as OT and IoT, workload traffic, and guest Wi-Fi traffic. Finally, PAC files provide a way to forward traffic between a browser and the Zero Trust Exchange. These are JavaScript files that set the proxy server address and optionally additional forwarding rules. This older technology is typically only used on devices without general-purpose operating systems where ZCC cannot be installed, since PAC files will only forward browser traffic. Note that Zscaler recommends installing Zscaler Client Connector on all user devices, no matter which option you choose. This ensures that ZIA is able to leverage your user's identity to apply policy and that they are protected with the same level of security in and out of the office. ZCC is included in your ZIA subscription for all your users. Finally, here is an example high-level design diagram for traffic forwarded to ZIA. On the left, we have corporate users. These corporate users have ZCC installed on their devices to forward their traffic to the ZIA service. There are 2 different tunnel modes for ZCC, ZTunnel 1.0 and ZTunnel 2.0, which we'll cover in more details later. ZTunnel 2.0 is recommended for general use as it encapsulates traffic on all ports and protocols, with some exceptions which will also be discussed in a later video. Next, we have VDI users. Since your VDI servers are located on your corporate network, these use a mixture of all 3 forwarding methods, depending on the limitations of the particular VDI technology involved. Then we have server and IaaS traffic. On-premise traffic is forwarded to the Zero Trust Exchange using GRE or IPsec tunnels, whereas IaaS traffic is routed via a connector placed in the IaaS cloud. Finally, BYOD and guest Wi-Fi traffic is forwarded via GRE or IPsec tunnels and secured using location-based and subnet-based policies. That's it for this video. Thank you for watching.